All right, we are nearing completion of our practice problem worksheet. The next problem that we are going to take a look at is our sex-linked traits. Sex-linked traits. So sex-linked traits are traits that lie on either the X or the Y chromosome. So remember in the body that you have 23 pairs of chromosomes. The first 22 pairs are called your autosomes, and those have things like eye color, hair color, intelligence, any other trait you can think of. And then that 23rd pair is the sex chromosomes. If you are a male, then those chromosomes are X and Y. And if you are female, then those chromosomes are X and X. So there are, the X chromosome is bigger, and because it's bigger, there is some extra space on it. And so on part of the X chromosome, we have a bunch of genes that actually don't have anything to do with gender. We talked about colorblindness being one of them. We talked about hemophilia, where your blood doesn't clot, being one of them. We talked about male pattern baldness being one of them. And all of these, thankfully, are recessive traits, but all of them are located on this X chromosome. And so if you are male and you have one of these disorders, then you are not going to pass this on to any of your sons. You're going to end up passing the X allele onto your daughter, if you have a daughter. And then if you are a female, you can have these on either X chromosome, but because you have two, you're less likely to get colorblindness because you would need to have two recessive alleles in order to be colorblind. So we see these disorders, these X sex-linked disorders, show up a lot more in females than in males. Okay, so we know that it's an inheritance pattern where the trait in question lies on one of the sex chromosomes. And for us, all of those are going to be on the X. We're not going to deal with any of them that are on the Y. So let's look at our problem. So we know that baldness is recessive and it's sex-linked. So again, look for which type of problem you're going to be doing in the problem itself. All of them will tell you what type of problem they are. We know that normal hair growth is dominant to balding, and we want to show the offspring possibilities that could come from the cross of a homozygous normal female and a bald male. Okay? All right, so before we go any further, and before we figure out our letters, let's take a look at some things to remember about sex-linked traits. So the first one is kind of a vocabulary. We talked about Mendel, but we also talked about this guy, Thomas Hunt Morgan, and he was working with fruit flies, otherwise known as Drosophila, and he realized when crossing these fruit flies, and they have two different eye color variations, so two alleles, there's a red eye and there's a white eye. He realized that when crossing them, he saw something interesting in the males. In the males, when he crossed a red and a white female with a male, he got half and half red eyes and white eyes in the males only, not the females. So he is the one that figured out that there are some genes that lie on the X chromosome that have more to do with autosomal traits than sex-linked traits or gender, because he was seeing eye color being on the X chromosome. And remember, we only need to worry about the ones that are on the X chromosome, and so these are the ones that are X chromosome. So all of the problems that you will see on the test or on the SOL are going to be these. Color blindness, and that's red-green color blindness, male pattern baldness, where you get the balding, receding hairline, and then the balding on the sides. Hemophilia is where the blood doesn't clot properly, and then a muscular dystrophy is a muscle weakening disease. And again, remember that because males only need to have one, so remember they have an X and a Y, and so only this X is going to have a letter. And so if they get the recessive on this X, then they would have the disorder. And that's why traits show up more often in males that are sex-linked than females. And then one more vocabulary word, just remember that females who carry an allele, recessive allele, are called carriers. They're normal in their phenotype because they have the dominant, but because they have that recessive hiding there, we call them carriers. Okay, so let's go back to our problem. Okay, so we need to figure out our letters. So we know baldness is sex-linked and recessive, and that means that normal is going to be the dominant. So I'm going to give big N is normal, and that means that little n is bald. Okay, and again, our cross is a homozygous normal female. So I'm going to put a big N there and a big N there. And remember, when you do sex-linked problems, the very first thing you want to do is write your X and Y chromosomes down, because remember, these traits are going to be located on the X chromosome. And then the male is bald, so he's going to have a little n. And remember, nothing goes on the Y, ever. Y is not carrying any of these traits. They are only on that part of the X chromosome, so there's nothing here for them to be on. Okay, and then we're going to take our parents and put them down the sides and across the top. And then we're going to combine them just like we would any of our other genetics problems. And then when we do our phenotype, we're going to remember that we have two things we can list for phenotype now. We can list normal hair growth or balding, and we can also list now the gender, because we can determine with the X's and the Y's whether or not the person is male or female. So let's look at the phenotype. So I have one, and this is a regular and a recessive, so we call that a carrier. And actually I have two of them. So I have two female carriers to two normal males. And it doesn't ask for genotype, but let's write it anyway. So 2xn to 2xny. All right. So two female carriers to two normal males. Okay, so remember, big things to remember for sex-linked traits. Nothing goes on the Y, okay? So don't put anything there. Secondly, remember when you do your phenotypes to also list the gender. So tell me whether they're male or female. And remember that males have this more because they only need to inherit one bad chromosome of the X, because they already have a Y. All right, stay tuned for your next genetics problem.